So, what if there is an unequal amount of protons and electrons in an atom? In that case, we give that atom a special name. We call it an ion, and then there's special ways to notate it as well. So an ion is an atom or a molecule, so it could be multiple atoms bonded together, that have lost or gained electrons. They are no longer neutral. More electrons than protons will lead to an overall negative charge. That's because electrons are negative, right? So more negative means you get a negative charge. More protons than electrons will lead to a positive charge, right? The overall charge for an ion is its number of protons minus its number of electrons. So we can see that in some of these pictures I've got down here. We have a hydrogen atom, it lost an electron. So now if we use this equation, we have 1 proton minus 0 electrons, we get H plus, or hydrogen plus. You can lose more than 1 electron, we will see that in a moment, or you can gain more than 1 electron. But let's look at a negative hydrogen ion. So this, we've got our proton in the middle, and then 2 electrons, it's gained an extra electron on the outside, so if we use our equation, it would be 1 proton minus 2 electrons is negative 1, so H negative. So if we're looking at that nuclear notation again, we could think about some other things, some other elements in their ionic states, like beryllium, for example. So beryllium has 4 protons. Let's say it has 5 neutrons, so it's beryllium 9, and it has, in this case, it's plus 2, so it has lost 2 electrons, right? So now there are 4 protons and 2 electrons, so we get a positive charge of 2. Or in oxygen's case, oxygen has 8 protons and it has gained 2 electrons, so it is now negative 2, right? One of the key things to note here, if a species has a change, then it must not be called an atom. So a species is the element, right? And if it's gained or lost electrons, we no longer call it an atom, we call it an ion. And then this is how we notate it. This is lost electrons, this is gained 2 electrons. Because this is telling us the overall charge, right? That can be a little confusing, right? Because this is a plus, even though we've lost electrons, but this is the overall charge of our thing. So I'm going to have you do some practice here now. You might see one of these charts on the test at the end of this unit. You should be able to figure out each missing piece of information using the periodic table and the information given here. So carbon 12 means that this is 12 is the mass number. All right, so there's a hint there. 12 is the mass number. So whatever number you see after the name is the mass of your atom or your element, right? Nuclear notation is this, right? We have protons and then mass number. Atomic number you can find on the periodic table. The mass number we know is the protons plus the electrons. Then we have number of protons, protons plus neutrons is the mass number. Then we have number of protons, number of neutrons, and number of electrons. So for this first one, I will go through it with you, and then I would like you to try and figure out the rest of these. On this first one, we have carbon 12, so that means our mass number would be 12. We have 6 protons, right? Our atomic number is 6, so whatever this is will be the number of protons we have. I'll just click in all this information. And then if we want to figure out neutrons, we can do mass number minus protons will give us neutrons, right? Because these two add together to get this. So you can do that backwards. And because this is not an ion, it doesn't have a plus 1 or minus 1, right? The number of electrons has to be the same as the mass number. Or, sorry, as the protons. Oof, man. All right, so I would like you to try and figure out the rest of these. Look at your periodic table to help you. So take a moment and see if you can figure these out. And then I will kind of quickly go through the rest of these. Okay, so hydrogen. hydrogen 1, we have 1 proton, and our mass number is 1, right? The atomic number of hydrogen is 1, 1 proton, 0 neutrons, right? Because our mass number is 1, and we have a proton already. And it's neutral, it's not an ion, so we have the same number of electrons as protons. This next one we can figure out because we know the atomic number is 8, so we can look at the periodic table. That is going to be oxygen. Um, because we know the mass number, we can write down our nuclear notation. 8 protons, 16 is the mass number. Mass number minus protons, which is the atomic number, is 8, right? The next one is sulfur. We have 16 protons, so that is going to be our atomic number, which we can then look at the periodic table to tell us that it's sulfur. We can see here that it has 2 more electrons than protons, so that's where we're getting this -2 from, and we can add these up to get our mass number, right? The final one is sodium 23. We can see that here, right? 23 is the mass number. 11 is the number of protons. The number of protons is the atomic number. We can do 23 minus 11 to get neutrons, and then it is a +1. So that means there needs to be 1 less electron than protons. So what you're going to do for your assignment today is you're going to read an article, which I'll post in ManageBack, and you're going to identify some of the factors that cause scientists to adapt or propose new models of the atom. There have been many, many models of the atom throughout time. It has changed and gotten better. So you're going to read about some of those, and then I want you to think about what role do these factors play in other areas of knowledge. So I'm going to just post those as discussion questions on the article, and so you'll read that and answer those 2 questions. And then another thing I wanted to show you, this video is kind of getting long, so I'll skip over this. We might talk about it later. But there is another video I'm going to post. And if you have time, I'd love for you to watch it and look at these questions and think about them. But what other forces act in the nucleus? Because we've only been talking about electrostatic or electromagnetic forces, right? We know that positives and negatives attract, and we know that like forces, so positive and positives, repel. So the questions you can answer by listening to this is if like charges repel each other and the nucleus contains a bunch of protons, why does the nucleus stay together? So there's got to be something else going on there, right? Can you explain why the larger a nucleus is, the less stable it is likely to be? So this video will help you understand those questions. But yeah, good luck on your reading and those questions. If you have time, watch this and have a great day.